the hardest part for you guys is adapting to radians because you've talked about degrees your whole life. They make sense. Radians doesn't make sense to you because it's the first time you talked about it. If I told you, oh, a circle is 2 pi radians and didn't tell you 360 degrees, 360 degrees would make no sense to you, right? But you're used to degrees because we've talked about degrees. We talked about degrees on triangles. We talked about degrees in circles, all those things. What 2 pi radians is just another way to measure that full angle. It's just in radians instead of degrees. It's like meters and kilometers. It's like using inches and using centimeters. One is just a different measure of another. Imperials and metrics, okay? So here we have 0 and 360 is the same as 0 and 2 pi. So basically, 360 and 2 pi are the same. Also, 180 degrees is going to be the same as what in radians, would you guess? 1 pi, because it's just half of that. We agree? So, what you need to know is degrees to radians, pi on top. So we use Dr. Pot. Degrees to radians, pi on top. And the reasons why that happens is we're either going to multiply by pi over 180 or 180 over pi, because we know that 180 and pi work together, right? They're the same. We also know that 360 and 2 pi are the same. Remember when you did conversions in like science and in math, you would always like line the conversions up. So you'd line up like 60 seconds and 1 minute, and you put them as a ratio, and then you'd multiply it to get minutes and seconds to get them to cancel off in science. You would do that to convert in science 10. But what we're doing is we're converting. You can just use the formula to remember it. So degrees to radians, pi on top. So you're either multiplying by pi over 180, or you're multiplying by 180 over pi, depending on if you're going degrees to radians or radians to degrees. For you guys, we're just literally just going degrees to radians for this year. That's it. Just the ones on the unit circle. Okay? So degrees to radians, pi on top. So what are we going to multiply by? Pi on top. So pi over 180. That's what we're going to do to convert. So for this one, it's 30 degrees. So what we're actually doing is we're going 30 degrees and we're multiplying it by pi over 180. Now, can I put if I put a pi in, will I ever get a fraction back out? No. Pi is a non-terminating, non-repeating decimal. 3.14159, blah, 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 blah. Okay? No matter how much you press math enter on your calculator, a fraction will not come out because fractions are for repeating decimals or terminating decimals, and pi is neither one of those. Okay? So if we want to reduce it, we can go 30 pi over 180 is what we're going to get out of this. And then we can take a 30 out of both, and we get pi over 6. So this is actually the same as pi over 6. Now, the quick way we could do it with our calculator, degrees to radians, is you can literally type the degree in, divided by 180, the degree, divided by 180, hit math, enter, enter, and add the pi back. Because if we put the pi in, it won't work. Okay? So our next one is 45, so try it out. Go 45 divided by 180 in your calculator. Math, enter, enter. Walk of shame every day, Sam. Walk of shame. It doesn't matter because you only have to worry about degrees and radians if you're pressing sine, cos, and tan button, right? So if we're not pressing the sine, cos, or tan button, degrees or radian mode doesn't matter. So you're going to go 45 divided by 180 because we're converting it. We're going 45 degrees times pi over 180. So what we're just going to do is we're going to do 45 divided by 180 and ignore the pi. We'll ignore the pi. So you go 45 divided by 180, math, enter, enter, and it reduces it for you. What do you get? A quarter. So what do we have to add back? The pi. So what is it actually? Pi over 4. Right? This reduces to a quarter, and then we have a pi beside it. Well, we're not going to write it like that. We're going to write it as pi over 4. So this one here is pi over 4. The next one is 60. So now what am I going to do? 60 divided by 180 So you get 60 divided by 180, math enter, enter. What do we get? 1/3. So what's it actually? Pi over 3. This one is 90. So you do 90 divided by 180. What do we get? Reduce it. 1/2. So what's it going to be? Pi over 2. Then here we have 2 pi over 3. Oh, it's going to be 2 pi over 3. Here we have 120 degrees. And type 120 divided by 180 in your calculator. What do you get? 2 over 3, right? So what's it actually going to be? 2 pi over 3. You finish it up. See if you can finish the unit circle, and then I'll add the answers. So here we have 135, which you should have gotten 3 pi over 4. And then this one is 150, which you should have 5 pi over 6. And then this one is 210, which you should have 7 pi over 6. And then this one is 225, which you should have 5 pi over 4. And then this one is 240, which you should have 7 pi over, no, that's a lie, 4 pi over 3. And then this one's 270, and you should have 3 pi over 2. And then this one is 300, and you should have, is it 5 pi over 3? I believe. And then this one is 315, and it should be 7 pi over 4. And then this one is 330, and it should be 11 pi over 6. You fill all those answers? In grade 12, you'll have them memorized. Don't worry. They'll just happen. Okay. So at the bottom of the notes I just gave you, we're going to look at the very bottom of it. It looks like this. Unit circle. I'm going to fill in the coordinates just so everyone has them to make sure they have them right. Your coordinates here should be, and Aaliyah, make sure you fill them in for anything. This one should be 1, 0. This one should be root 3 over 2 and 1/2. This should be root 2 over 2, root 2 over 2. This should be 1/2 and root 3 over 2. This should be 0, 1. Everyone doing okay so far? Does everyone have those? Okay. Now these, all your x's should be negative because they're in quadrant 2. And just repeat that flipped. So it's 1/2 root 3 over 2, root 2 over 2, root 2 over 2, and then root 3 over 2.5. And then negative 1, 0. Now in quadrant 3, both your coordinates should be negative, correct? It should be negative x, negative y. And this just reflects down. All the 30s will stay the same. So 30 is going to be root 3 over 2.5, root 2 over 2, and 1/2 root 3 over 2. So once you have one quadrant, all the rest should just follow suit. So this one's going to be negative root 3 over 2 and negative 1/2. Negative root 2 over 2, negative root 2 over 2, negative 1/2, and negative root 3 over 2. And then this is 0 and negative 1. And this, all my x's are positive, but my y's are negative. So I'm going to get root 3 over 2.5, because that's for the 30s. Root 2 over 2 and negative root 2 over 2, because that's for the 45s. And then 1/2 and root 3 over 2. So it just repeats, right, all over the place. So make sure you have them right. Now, the unit circle is what? Cos and sine, sine then cos, tan, what is it? What's the unit circle? Cos then sine, because it follows Calgary Stampede, correct? So we have Calgary Stampede, so it's always cos theta, sine theta. So if I ask you for cos of 240, what's it going to be? What's cos of 240? Negative a half. I go to the x at 240 and I give my answer. Sine at 240, negative root 3 over 2, right? What if I say cos of 330? Root 3 over 2. And sine of 330? Negative a half, right? Okay, I'm going to get you guys to try these two. A and B for now. I'm going to use 240. I'm going to use 120 because I just did 240. A and B. Sine of 30 is what? Is 1/2. It's the y. Now remember, I can type it in my calculator, can't I? What mode do I have to be in? Because I'm going to press the sine button. Degree, because what's beside it? A degree. Now if I had pi over 6 beside it, I would have to be in radians because that would be a radian measure. It's the same thing. Okay? I'm going to show you that it's the same thing. So type sine 30 into your calculator. Everyone, sine 30. Make sure you're in what mode? Degree. So type in sine 30 and what do you get? You get 0.5. Now, go mode. Mode is the second from the top left. And go to radian. Now type sine 30 in, just to prove a point. Is it the right answer? No, because you're typing sine 30 degrees, are we not? In what mode? Radian mode. So does that work? No. But if I use its radian measure, which is pi over 6, try it out. Go sine pi divided by 6 now. Try sine pi divided by 6. You should be in radian mode, trying sine pi divided by 6. What do I get? 0.5, so it's the same answer. Why? Because pi over 6 is radians for 30 degrees, correct? So radian mode needs to be used when you have a radian measure beside your sine, cos, or tan. And degree mode needs to be used when you have a degree measure beside. Make sense? Okay. Cos of 120. So I go to 120 and I pull off the x, which is negative a half. Cos 120 equals negative a half. Then if I went, do this in your calculator, you're in radian mode right now, right? So if I said cos 120, I'd have problems. But 120 is the same as what? 2 pi over 3, correct? So go cos 2 pi over 3. Cos 2 pi over 3, because we're in radian mode. What do I get? Negative a half, because 2 pi over 3 is just the radian measure of 120. They're the same thing. It's like saying your conversions between, I don't know, inches and centimeters, right? If I give you the conversion of what one is to the other, they're the same thing. There's different units. Okay, what did I tell you about tan though? Can we pull tan off of Calgary Stampede? There's no like Calgary Stampede, right? It's Calgary Stampede, so there's no tan. But I did give you an acronym. It's tan what? Tan theta equals tan. Did I give you an acronym yesterday? Your Xbox? Did I give that? Didn't I? Yes. Tan your Xbox. Tan your Xbox. Xboxes need vitamin D. They don't really, but we're going to pretend they do. They'll crash without it. So, if I want to find tan, can I find it really quick? No. I'm going to have to do the y value divided by the x value, correct? So I go to 315. You'll find out that 45s are the best thing on the planet. So at tan 315, I have root 2 over 2 and negative root 2 over 2. So that's my x and that's my y. We agree? I want tan 315. So I'm going to go equals my y divided by my x because it's your Xbox. What did I tell you? Do we stack fractions? No, we write fractions side by side. So the moment you go to stack them, be like, wait a second, something is wrong here. I can't stack. So I'm going to get my y, which is negative root 2 over 2. And I'm going to divide it by root 2 over 2. When I divide by a fraction, I invert and multiply, or flip and kiss. So root 2 over 2 times 2 over root 2. So I'm going to get negative 2 root 2 over 2 root 2. These cancel and become a 1, so my answer is just negative 1. All the 45 degree reference angles are going to come out as 1s or negative 1s. Why? Because your x's and y's are the same value, right? Your x's and y's are the same value. In quadrant 1, you would do root 2 over 2 divided by root 2 over 2, which is positive 1, right? So if I go here, we would do root 2 over 2 divided by root 2 over 2, which is positive 1. If I go here, we do root 2 over 2 divided by negative root 2 over 2, which is negative 1. If I go here, I do negative root 2 over 2 divided by negative root 2 over 2, which is positive 1. And if I went here, it would be negative root 2 over 2 divided by root 2 over 2, which would be negative 1, right? So the 45s always get you 1. So you'll notice that when you get a 45, you're happy. So they're easier to do. Okay, what about tan of 90? So what is the coordinate at 90? 0, 1, correct? So this is my x and my y. And tan, I have to do what divided by what? Y divided by x. So it's going to be 1 over 0. Can I divide by 0? No. So when you see 1 over 0, your answer is actually undefined. There is no answer, so you have to write undefined. Now we're going to flip over. We're going to not do 2 and 3 for right now, but we're going to go to 4. We'll come back to 2 and 3. So here it says the point xy is located where the terminal arm of angle theta and the unit circle intersect. Determine the coordinates at that point. You have them. Go to your unit circle, tell me what they are. So I want the point at 135. So I go to 135 and I give the coordinate. What is it? Negative root 2 over 2 and root 2 over 2. You do 210. What's 210? Negative root 3 over 2 and negative 1/2. Why are they both negative? Make 210 falls in quadrant 3, right? Between 180 and 70. Okay, now opposite. I'm going to give you the coordinates, and I want the angle between 0 and 360. So if I give you a negative and a negative coordinate, where am I going to look? Am I going to start looking in quadrant 1? No, where should I look? Quadrant 3. If both of these are negative, you go to quadrant 3. So go to quadrant 3. What's negative root 2 over 2 and negative root 2 over 2? 225 degrees. Don't forget the degrees or else it's a radian measure. Because how can you tell it's degrees? It has a degree symbol. Okay, then we have negative 1/2 and negative root 3 over 2. We're in quadrant 3 again, right? Because they're both negative. Where is that at? 240. Example 6 says determine the exact solutions. Exact solutions means do not type those in your calculator. Exact solution means go to your unit circle and pull off the fractions. That's what exact solutions means. So don't go degree mode, sine 315 plus sine cos 150. Don't do that. We are using our unit circle. So sine 315. Go to 315 and pull off which fraction? The x or the y? The y. What is the y at 315? Negative root 2 over 2. So this equal sign runs down the left. Plus cos of 150. Go to 150 and pull off what? The x or the y? The x. Root 3 over 2. Negative root 3 over 2. Now we have a common denominator. So we just write it all over 2. So you have a common denominator right over one denominator. And then we just write negative root 2 minus root 3, and we're done. They're not like radicals. I can't put them together. Correct? Cred, we have a tan. What do we have to do to get tan 225? Can we just pull it off our unit circle? No, we're going to have to do some work. So if I want tan 225, I need to get the coordinate from 225, which is negative root 2 over 2 and negative root 2 over 2. And which do I divide by which? Tan your x box. So we're going to go negative root 2 over 2, the y, divided by the x, negative root 2 over 2. What happens when I divide two numbers that are the exact same together? You get 1. And a negative divided by a negative is a positive 1. So I'm going to get 1 minus, what's sine 135? Root 2 over 2. Now how do I put them together? I need a common denominator. So this is 1 over 1. I can multiply by 2. So I'm going to get 2 over 2 minus root 2 over 2, which is 2 minus root 2 all over 2. You guys try C, D, E, F. See if you can do it. Sine of 330. What is y at 330? Negative what? A half. And then cos 225 is negative root 2 over 2. So we're going to get it all over 2. We're just going to get negative 1 minus root 2. Done. Tan 330. So that's a big one. So at 330 we have root 3 over 2 and negative a half. This is my x, this is my y. So I'm going to have to go negative a half divided by root 3 over 2. This is that one that we had to rationalize, kind of ugly yesterday. So we get negative a half times 2 over root 3. The 2's can cancel, and I get negative 1 over root 3. And then what did I tell you have to do? Rationalize, right? So multiply by root 3. So we get negative root 3 over 3. Minus sine of 30, which is a half. I'll let you leave it at that for now. But I'll show you what we would do. You'd have to multiply this by 2 and multiply this by 3 to get common denominators. So we get negative 2 root 3 over 6 minus 3 over 6, which is actually negative 2 root 3 minus 3 all over 6. And we do these all next year, but we also add 3 other trig ratios, the secondary trig ratios, which is secant, cosecant, and cotant. And we add radian measure. So it's quite beefy. Sine 270, so I go to 270 and y is negative 1. Cos at 90 is 0, so you should have got negative 1. Sine 45 is root 2 over 2. Cos of 30 is root 3 over 2. Minus cos of 45 is root 2 over 2. Sine of 30 is a half. And so we get root 6 over 4 minus root 2 over 4. And you can write it all over 4, and it's root 6 minus root 2. So I'm going to give you a little bit to work on. You're going to get about 10 minutes to work on it, and then we're just going to review quadratics because you guys have your cumulative, what's it called, on Thursday next. So I'm going to basically just make you do this one question. Page 98, you have to determine if they're the same without using technology, so you need to use your unit circle. And then I want you to do this one. Cos 135 minus sine of 300. So you get, I don't know, 5 to 10 minutes to work on those, and then we're going to review quadratics.
Have you asked for solution? Yeah, I'll ask today. And probably like, five-step process.
Vertex. What's the vertex on this? -4, -6. Opposite, same. Is it a max or a min? Because it's concave. Down, because your leading coefficient is negative. So it's going to be a maximum when y equals -6. So this graph starts at -6 and the whole thing's below it. What's the domain of every quadratic? X such that x and m are the real numbers. What's my range? The whole thing is concave down, and my highest value is -6. So it's going to be y such that y is less than or equal to -6, YER. What's my axis of symmetry? The x of the vertex. So it's x equals -4. When I want to convert to standard form, what's the very first thing I'm going to do? Expand. I'm going to write that x plus 4 twice. So I'm going to get y equals -3, and then x squared plus 4x plus 4x plus 16 minus 6. So y equals, and then distribute, -3x squared minus 12x minus 12x minus 48 minus 6. Select like terms, -3x squared minus 24x minus 54. What's my y-intercept at? The constant. 0, -54. Y equals -2x squared minus 4x plus 3. What am I going to want you to do? convert to vertex form, which means you have to complete the square. It's the plus the blank minus the blank. You're doing that. Then I'm giving you this. Determine the equation. When I ask you to determine the equation, what form do you have to put it in? Vertex form. Try them out. If you're not done, we're going to go through it anyways. So, what do? We take the negative 2 out. We go square bracket. Then what do? Square bracket, round bracket, and we take it out of the first 2. Negative 2 out is positive x squared. Negative 4x divided by negative 2 is positive 2x. Plus blank, minus blank, square bracket plus 3. How do we get the blank? We take our b, which is our new b, divided by 2, and square it, which is 1 squared, which is 1. We don't skip any steps. So we get y equals negative 2x, look one back, plus 1 squared. Don't forget to multiply these. Negative 2 and negative 1 is positive 2 plus 3. And y equals negative 2x plus 1 squared plus 5. The bottom one, you're going to label this P and Q. And then this is 0, 3 is my coordinate, x and y. And then I always, even if I ask for it in standard form, fill it into A, x minus P squared plus Q. So I'm going to get y, which is 3, equals A, x is 0 minus 2 squared plus 6. 3 equals negative 2 squared is A times 4 plus 6. Then I have to subtract my 6. Negative 3 equals A times 4, divided by 4. A equals negative 3/4. And so we get y equals negative 3/4 x minus p, so x minus 2 squared plus 6.
Why did you use the vertex for it?
The vertex is 2 and 6.
Oh.
So make sure you're studying sequences and series. Sequences and series.